This video is about thyristors. Similar to the transistors, thyristors are also the switching devices. And we know that transistors are the very small electronic components that have changed the world a lot. And we can find them in most of the electronic devices like mobiles, calculators, earphones, laptops, etc. We find transistors in almost many applications, but it does not mean that it can be used in every application because the transistors can be used for amplification and switching purpose. But the limitation of the transistors is that they cannot handle the higher current. So, in order to overcome these issues and also such some more issues that we will discuss later, we use thyristors. You must have heard the word SCR, silicon controlled rectifier, synonymous to the word thyristor. They are used interchangeably, but note that SCR is also a kind of thyristor. We have various kinds of thyristors such as SCR, GTO, IGBT, etc. But since SCR is most widely used, we use the terms SCR and thyristor interchangeably. This is a symbol of a thyristor. Thyristor has three terminals: anode, cathode, and gate. Like a diode, where the current flow is unidirectional, thyristor is also a unidirectional device, which means current flows only in the one direction. This is a schematic diagram of a thyristor. You can observe there are four layers of P and N type semiconductor materials alternatively. You can see there are three PN junctions in series because it is of four layers. So, a thyristor is a four layered three junction semiconductor switching device. And the gate terminal used here is used to trigger the thyristor by providing small voltage at the gate terminal. Here you can look at the equivalent circuit for the schematic symbol of thyristor. You can observe the base of transistor T1 is connected to the collector of transistor T2, and the base of transistor T2 is connected to the collector of the transistor T1, which means both the transistors are completely dependent on each other for conduction. Even if there are voltages at anode and cathode, the transistor won't get turned on until there is a base current. So, a gate terminal is used at which a small voltage is applied that causes current at the gate terminal and makes the transistor T2 on, and which makes the transistor T1 automatically on. Now you can understand the difference between the transistor and thyristor, that in thyristor, now if you remove the gate voltage also, the both the transistors, that is the thyristor device, will be turned on until we switch off manually. Whereas in transistor, when there is no base current, the transistor gets off. So, in applications such as alarm systems, we cannot use transistors, but we can use thyristors. But for applications like audio systems, we use transistors but not thyristors because we need continuous control over the amount of current flowing, because we need to track variations in the sound. Now the question is, how are they different from FETs? We know that FETs are the voltage controlled devices and they can only switch DC current. But thyristors are the current control devices and they can switch both DC and AC current. For example, thyristors can be used in very large load applications, for example, like light dimmers. It controls when the power should reach the light. This is the circuit used to obtain the VI characteristics of the SCR. Anode and cathode of the thyristor is connected to the main supply through the load, and a voltage source ES provides a required voltage at the gate terminal. This provides the gate current from gate to the cathode. Now, if you look at the VI characteristics of the SCR, there are three basic modes of SCR: reverse blocking mode, forward blocking mode, and forward conduction mode. The reverse blocking mode can be obtained by making the cathode more positive with respect to the anode. So when we make cathode more positive with respect to anode, junctions J1 and J3 gets reverse biased and J2 gets forward biased. So thyristor does not conduct. And care should be taken that the positive voltage applied at the cathode should be less than VBR, that is the breakdown voltage. If the positive voltage applied at the cathode crosses the VBR, the thyristor may get damaged. In reverse blocking mode, the switch at the gate terminal is kept open. Now, when the anode is made more positive with respect to cathode, with the gate switch open, then the junctions J1 and J3 gets forward biased and J2 gets reverse biased. So at the junctions J1 and J3, a small current flows which is called the forward leakage current. But we know that this forward leakage current is very small and it is not enough to trigger the SCR. Therefore, SCR acts as an open switch even in the forward blocking mode. Now, if we keep on increasing the forward voltage with the gate circuit open, an avalanche occurs at the junction J2 and now the SCR goes into the conduction mode. So we have seen two types of triggering methods for SCR, that is one with directly gate triggering and the second one is the forward voltage triggering. Even we have other types of triggering such as dV by dt triggering, temperature triggering and light triggering. In forward blocking mode, junction J2 is reverse biased, right? So, because of the acquiring of charge across the junction J2 behaves like a capacitor, and we know that when there is a sudden rise in the forward voltage, the charging current through this junction capacitance will make the SCR turn on. This is known as the dV by dt triggering. In temperature triggering, because of the large applied voltage collected at the junction J2 in the forward blocking mode of thyristor, it will cause a leakage current, right? So this increased leakage current increases the temperature of the junction J2. So the depletion layer decreases and at some high temperatures, the depletion layer gets removed and the SCR turns to the on state. In light triggering, a hollow is made at the inner P layer as shown in figure. At this hollow, optical fibers are used to direct a light of particular wavelength. When the intensity of this light reaches a certain value, the SCR gets turned on. Such type of SCR is called as light activated SCR, that is LASCR. LASCR are used in high voltage direct current transmission systems. This is about introduction to thyristors. If you like the video, subscribe to my channel and share the video. And if you have any doubts, post in the comment section.